0 and negative exponents. So we've worked with exponents in powers, but we've really only worked with positive exponents. So now we're going to take a look at what happens when we deal with 0 as an exponent and a negative integer as an exponent. So 0 exponents, any non-zero number to the 0 power is 1. Pretty straightforward. So if you see a 0 in an exponent, doesn't matter what the base is, we automatically know that the value of that power is 1. So we're going to evaluate each expression. 3 to the 0 power. Again, the minute you see that it's to the 0 power, it's not 0, and this is kind of one of those things to wrap your head around, it's equal to 1. And when we think about our powers, we're dealing with multiplication and we're dealing with division. So we can never multiply things and get 0 unless one of the factors is 0. And since what we're multiplying here is this base, the only thing I can come up with here is a 1. I can never come up with a 0 unless the base is 0. And if the base is 0, then things get kind of weird here. So 3 to the 0 power, that's going to be just a 1. B to the 0 power, so we've got a variable here, that's also going to be just 1. Let's look at one more. 7 to the 0 power times 7 to the second power. So 7 to the 0 power is 1, and 7 to the second power is 49. So we end up with 1 times 49, which is 49. All right, so our 0 power, pretty straightforward. Let's start talking about negative exponents. However, we've dealt with positive, we've talked about a 0 exponent, let's talk about a negative exponent. For any integer n and any non-zero number a, we're not talking about 0 as our base, a to the negative n power is the reciprocal of a to the n. So remember, if we talk about reciprocals, if I multiply those two together, I will get 1. So a to the negative n times a to the n is going to be equal to 1. Here's how this kind of works when we think about it as how we actually work with it. 4 to the negative second power. That's equal to 4 to the negative second power over 1. We can always make it a fraction by putting it over 1. So 4 to the negative second power really means 1 over 4 to the second power. So again, if I take this times 4 to the second power, that would be equal to 1. So they're reciprocals of each other. So how I like to think about my negative exponents. A negative exponent means the base is in the wrong part of the fraction. So the minute I see a negative exponent, I automatically start to think fractions. So I'm going to take that power and write it as a fraction. We're going to move the base to the other part of the fraction and make the exponent positive. So I like to think about this, and this is very non-mathematical, but this is what kind of makes it work in my head. I think about that negative exponent as telling me that it's unhappy, because when something's negative, it's not happy. It's not happy where it is in that fraction. That base needs to move. So here I have 4 to the negative second power. The base of 4 is in the wrong spot. So I'm going to move the 4 to the denominator, because here it's in the numerator. I'm going to move it to the denominator. And since it's now in the right spot, its exponent becomes a positive. So 4 to the negative second power is the same thing as 4 to the second. 1 over 4 to the second power. So as I'm working with my fractions, that's kind of how I can move things around. All right, so we're going to simplify each of these expressions, just like a regular fraction. But now I've got this c to the negative fourth over c to the fourth. I'm going to use that same rule I applied here, where I'm going to keep the base and put it in the numerator and subtract my exponent. So negative 4 minus 4 gives me negative 8. So I have 1 times c to the negative 8th all over 3. Now remember that negative 8 in the exponent reminds me that the base is in the wrong spot. So I then moved the c to the denominator and change that negative 8 to a positive 8. So I end up with 1 over 3 c to the 8th power.